Hello, welcome to Algebra 1 with Miss Andrea. Um, Today we're going to continue on with graphing the quadratic functions. And last lesson, we got into just some key terms and the questions that are going to be answered in this unit. So today we're going to actually we're going to begin graphing some of these items, some of these functions. So we have Algebra 1 lesson 3b.2. This is unit 3b, which is graphing quadratic equations, page 2. And right, so I have up here some graph paper. Now you should have some graph paper at home in order to graph equations. And the standard equation for a quadratic equation is going to be y equals x squared. Now, if it was a quadratic function, it would be f of x is x squared. You notice the only thing that changed is the y turns into an f of x. So you know that this f of x is a y. And you can only write it as a function if it is a function, if it looks like a function, which means it passes the straight line test, or for every input, there's exactly and only one output. Okay, so how would we graph one of these quadratic equations? Well, let's look at this basic equation of y equals x squared. Well, remember, x is our input value and y is our output. And our domain, there's no rules against what we can put in for x, so our domain is going to be all real numbers. And so let's start just making a chart. So we've got x and we've got y, input and output. If I put in 0 for x, what am I going to get? Well, 0 squared is 0. Okay, what if I put in 1? 1 squared. Okay, that's 1. 2 squared, is it 2? No. 2 squared is 4. 4 squared is 16. I don't think that one's going to be able to fit on this chart, but let's look at this. So we've got the point 0, 0 right here. This is point 0, 0, right? Then we've got the point 1, 1. And then we've got the point 2, 1, 2, 3, 4. I didn't put 3 on there, but it's 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4 won't match. But that doesn't really help us determine a parabola because we only really see one side of it, right? So we're going to have to input some negative numbers too. What if we put in -1? What is -1 squared? It's 1. -2 squared is 4. -3 squared is 9. So you can see that these are going to be exactly opposite each other. You can already see the parabola forming here. Okay, so, oops, that was horrible. Let's see if I can do a little bit better job. A little bit better. Not the best. All right, so we have our parabola forming. We have here our vertex. This is our vertex in our key terms. We talked about what a vertex was. It's where it changes direction. So it's going down, it hits the vertex and it goes back up. This vertex is also known as the minimum or the maximum point, right? This is, and this open upwards, right? So its end behavior as x approaches infinity is infinity. Its end behavior as x approaches negative infinity is infinity, right? And then what else? Oh, we have the axis of symmetry is right here, right down the middle on x equals 0, right there. What else do we see? So you can see on the axis of symmetry that these points are exactly symmetrical to each other. They're the same distance away from that axis of symmetry, right? So this is your standard quadratic parabola graph, what the standard formula would look like. And one way you can always, whenever you're asked to graph anything, just pick some numbers, plug it in for the inputs, get some outputs, graph the dots and see where it takes you. That's always one way to graph something. Now, maybe I don't feel like doing all of that work. when I graph it. So one of the things that's helpful is to know certain key terms, like where's the vertex? That was important when we were graphing that last question. And if I was asked where's the vertex, I could graph it and look and see where the vertex is. That is one option. However, here's another option. You have a formula. Okay, so this formula will let us know, we can use this formula to figure out what the vertex is for any equation, quadratic equation. Now, if you notice, this has got B's and A's in it. So that means it has to be in what? In standard form. Remember, ax squared plus bx plus c. That's standard form. So we're to use this formula to determine what the vertex is. Or you could go and graph it all and see if you can figure it out that way. This is going to be a lot faster. So let's identify A. A is 2, B is -8, and C is 3. We didn't really need C. It's not in our formula. So the V here, right next to the X, means it's the X that's in the vertex. And we have a V here next to the Y as well. It's the Y of the vertex. Because remember, a vertex needs to be in an ordered pair. XV, YV. Okay, so we're going to get those two numbers. So in order to get the X, I'm going to do -B. Well, B is -8, so the opposite of -8 is a +8 over 2A. So 2 times 2, which is 8 over 4, which is 2. So XV is 2. And now we need to find YV. How you find YV is you plug in what you got for XV into your equation and figure it out. So we're going to take what we got here, 2 for XV, and plug it into all the places where we see X. I'm going to do this in a different color for us. So I've got 2, and then instead of X squared, I'm going to plug in 2, because that's what I found for X squared, times 2 squared, minus 8 times 2 plus 3. Now you can plug this all into your calculator and get an answer. That's going to be 4 times 2 is 8, minus 16 plus 3 is -8. It should be -5. Let's plug it into our calculator, because you always want to use your calculator just to be sure. -5. So I got YV equals -5. So it's 2, -5 is my answer. What is the vertex? It's 2, -5. And when you're asked what's the vertex, it should always be in ordered pair form for your answer. All right, so I've got some practice problems here for you. I want you to go ahead and figure these out. You should have written that formula down in your notebook, taken notes, so you could easily figure these out. All right, pause the video. Welcome back. So remember, our formula is -B over 2A, and that is our XV, our vertex, our X value for the vertex. So we're going to take this and we identify A is -1. And notice that negative there for the leading coefficient. Remember, those are some terms we talked about. That negative is going to tell us that it's going to open downwards and not upwards. B is 2. And C is 3. We don't really need to know C, but that's okay. -B, or the opposite of B, is going to be -2. And then 2 times A, it's 2 times -1. So it's -2 over -2, which is +1. So now we need to plug that into our formula. -1 squared plus 2 times 1 plus 3. This is interesting. I want to make sure to point this out since we have a squared here. This negative at the beginning does not affect the square. You know, normally when I say you have a negative number, you do -1 squared, but we're not plugging in the -1. Negative is in the formula. What we're plugging in is 1. So when you plug this into your calculator, you have to do negative parentheses 1 squared. So you're only plugging inside of the parentheses what you're inputting into X. That negative is outside of whatever X is, okay? So you need to have it set up where the 1 is in parentheses by itself. Don't take on that negative that didn't come with that 1, okay? All right, so we're going to plug this into our calculator, and we're going to get -1 plus 2 plus 3 is 4. Let's see. Negative parentheses 1 close parentheses squared plus 2 parentheses 1 close parentheses plus 3 enter is 4. All right, so my vertex, I forgot what it was called for a second. My vertex is 1, 4. All right, so moving on to the next next equation here. Excuse me. A is 3, B is 12. C, I don't see a C, so C is 0. Okay, if it's not there, then it's 0, it's nothing. All right, so negative B, or the opposite of B, is going to be -12 over 2 times A, which is 3. -12 over 6 is -2. So we've got -2 here. And then let's plug in -2 to our equation. We've got 3 times. In this case, you definitely need to have the -2 all together inside the parentheses, right? You have to keep that negative paired up because you're plugging in the negative. -2 squared plus 12 times -2. This is what I'm going to enter into my calculator. Should be something like 36 minus 24, so 12. Something like that. Let's see, 3 parentheses -2 close parentheses squared plus 12 parentheses -2 close parentheses equals -12. -12. All right, moving on. Here we have A is 1, B is -6, and C is 4. So let's plug these in. The opposite of B is going to be +6 over 2 times A, which is 1. So 6 over 2, which is 3. So XV equals 3. So 3. And then let's plug it in. 3 squared minus 6 times 3 plus 4. That's what I'm going to enter into my calculator. 3 squared minus 6 times 3 plus 4, enter -5. So we get -5 here. Our vertex is 3, 5, 3, -5. And our last one here, I've got an A being 2, B, there is no B, so B is 0, and C is -7. The opposite of B is, there is no opposite. 0 has no sign, so there can't be an opposite, so it's just 0. Over 2 times A is 2, so 2 times 2, 0 over 4 is still 0. So our X for the vertex is going to be 0. Then we're going to plug that in and see what our Y is. So 2 times 0 squared minus 7. 0 times itself is 0, times 2 is 0, minus 7 is going to be -7. So that is, remember, our Y for the vertex, so -7. I have all 4 vertexes here. Hopefully you got the same thing as me. All right, moving on. You didn't think the lesson was over, did you? Well, we have just a little bit more, because this is all about graphing. So far, we're really only looking at the vertex. Well, why were we looking at the vertex? Because it will help us with graphing. So there are some other things besides the vertex we should look at that will help us with graphing. Graphing is just the kind of like the pinnacle, the most important, the one that we need to know for sure. So these are other key features, and in your homework, you may be given a chart that you need to fill in, and it may actually have more things on here, such as like end behavior and domain and range, things like that, that we'll get to a little bit later. But right now I want to focus on these items. What is the vertex? does the graph, it doesn't say it here, but it's supposed to say, does it open upwards or downwards, right? The axis of symmetry, the Y-intercept, and the X-intercept. So I'm going to do one with you, and then I want you to do the second one on your own. And we're supposed to graph them and fill out this chart, okay? So let's look at this. Remember, what is our formula to find a vertex when it's in standard form? Well, it's going to be negative b over 2a, which sounds very familiar to our quadratic formula, remember? So if we have a equals 1 and b equals 4, we can figure this out. Negative b over 2a. So negative b, the opposite of b is 4. Negative 4 over 2 times 1 is 2. So the vertex is going to be negative 2. Negative 4 divided by positive 2 is negative 2. Now we need to figure out the y value. So we're going to plug in negative 2 wherever that is. So negative 2, make sure it's in parentheses, squared, plus 4 times negative 2 plus 3. I'm going to plug that into my calculator, okay? Open parentheses, negative 2, close parentheses, squared plus 4, open parentheses, negative 2, close parentheses. When you use parentheses in your calculator, you don't even have to use a times symbol because the calculator knows the rules that if they're next to each other, they're going to be multiplied, okay? Plus 3. And I hit enter and I get negative 1. So negative 2, 1, 2, negative 1. Right there, that's our vertex. Now, is this going to open upwards or open downwards? And that is determined, if you remember from our key terms video, lesson 1, page 1, from the leading coefficient. That means the coefficient that's in front of the variable that's being squared. So in this case, we have a leading coefficient of positive 1. And since it's a positive 1, we know it's going to open upwards, okay? If you look at this one, it's got a negative. So this one is going to open downwards. All right, well, that's kind of helpful because we know what direction it's going to be, but we don't know how wide or skinny it's going to be. So we got to kind of figure this out. Axis of symmetry. Axis of symmetry, we know, goes straight through the vertex. We already kind of talked about that. So we can see, remember our first graph we did in this lesson, we had an axis of symmetry that was right through the point of origin here, right here, for this standard equation. Let's look. We had a standard 2, 1, 2, 3, 4 right here, and then 9. We had a standard parabola that looked something like that. That was y equals x squared in orange, okay? And then, so we had our axis of symmetry was right there. The x equals 0. So an axis of symmetry is a line. It's like this imaginary line that you're going to fold the parabola up in half on. And you notice it goes through the vertex. And the line always starts with x equals. So what is x equals? Well, x equals what the vertex, the xv is in the vertex. So negative 2. Right here, negative 2, because x is always negative 2 in this line, this axis of symmetry right here. So we know everything that's going to be on the right will be mirror imaged on the left, and so forth, back and forth. All right, so y-intercept. Let's look at this. How do we find the y-intercept? Well, we find the y-intercept by putting 0 in for x, and then we'll get the y-intercept. So let me go ahead and erase some of this so I have a little bit more room. I'm going to put 0 in for the x value, and then it'll determine what my y value is for my y-intercept. 0 squared plus 4 times 0 plus 3. Well, I really don't need a calculator for this because 0 squared is 0, 4 times 0 is 0, and I'm just left with plus 3. So my y-intercept, remember my x was 0, my y is 3. 0, 3. So 0 means I'm not going to the right or the left, and it's going to be 1, 2, 3. It's going to be right there. Okay, now because of my axis of symmetry, I know that this dot is 2 away from the axis of symmetry. So the same y value, I'm going to go 2 in the opposite direction away from the axis of symmetry and say I have a dot there as well. So we can already begin to see a little bit of the shape of our parabola here. Now we need to find the x-intercepts. These are the solutions or the roots or the zeros that we have. We've practiced this in the past, right? We've seen this. We know how to do this. One way is greatest common factor. We could factor it out. We could factor for a trinomial, and let's do that. So let's look for things that multiply to be 3, but add to be 4, okay? Well, the only one, and the one that I can think of right away, is 1 times 3 makes 3, and 1 plus 3 makes 4, right? So 1 and 3. So let's factor this out. We know that, I'm going to erase this line in the middle here. It's a little too long for me. I know that I've got an x at the beginning of each of my factors. And I know that both of my factors are going to be, the signs in my factors are going to be the same, and they're both going to be positive or plus. So I've got plus on both of these. And then I've got 3 on one and 1 on the other, and they're both equal to 0. So if they're both equal to 0, I can set them each equal to 0. X plus 3 equals 0, and x plus 1 equals 0. And then I'm going to solve for x. So x equals -3. And x equals -1, okay? So my x-intercepts are going to be, I've got 2 of them. X-intercepts means my y will be 0, and one will be -3, and the other will be -1. So let's look at this. I've got -1, and I've got -3. And if you notice, they're equidistant from the axis of symmetry, right? Because the axis of symmetry mirrors one side to the other. And so we can see our parabola right here in the blue. We got our parabola. So now pause the video and go ahead and do number 2 all on your own. All right, welcome back. And let's do it, we'll do it in green this time. All right, so what is the vertex? -b. So -4 is our b, so the opposite of that is going to be 4 over 2a. So 2 times -2. So 4 over -4 is -1. So -1 is our x value for the vertex, right? Then let's plug that in and see what we get. So -2 times -1 squared minus 4 times -1 plus 4. Let's see. -2 plus 4 is going to be a +4 plus 4 is 6. I'm going to say it's 6, but let's use a calculator just to be sure. -2 times, open parentheses, -1 close parentheses squared minus 4 open parentheses -1 close parentheses plus 4 equals 6. All right, so 1, 6. So let's go over 1 and up, -1, sorry, -1 and up 6. 1, 2, 3, 4, 5, 6. So that's our vertex. Wow, that's pretty high, isn't it? But remember, we already filled out this one down here. It says it opens down. Oops, I guess I should have used pink. And what's our axis of symmetry? Our axis of symmetry is right here. And it is our XV value. So I'm going to say X equals -1 to write that answer to the axis of symmetry. Now, where is my Y-intercept? To find my Y-intercept, I need to plug 0 in where X is. So I'm going to put 2 times 0 squared minus 4 times 0 plus 4. That's 0, that's 0, so we've got 4. Y is 4, X is 0, 0, 4. 0, 1, 2, 3, 4. These are all right on top of each other, aren't they? All right, so now we need to solve for X. We need to find out what the X intercepts are, the solutions, the roots, the zeros. And so let's look at this and see if we can factor it. A common factor we can take out is 2, right? I can see that they're all even. So we can have 2x squared, excuse me, negative 2, right? Negative 2 plus 2x plus, oops, minus. Should be a minus 2. All right, so negative 2x squared divided by negative 2 is just going to be x squared. Negative 4x divided by negative 2 is 2x. Positive 4 divided by negative 2 is negative 2. All right, so we're good. We've got that, and that's set equal to 0. So I'm going to divide out the negative 2 so it can cancel out, right? And that's still 0 on this side. And so now we need to factor. So I need to find something that multiplies to be negative 2, but adds to be positive 2. So we've got negative 2 and positive 2. It's 2 and 1. That's not going to give me a positive 2. I don't think that we can factor it after we've taken out a greatest common factor. I wonder if we could factor it before we took out the greatest common factor. If we multiplied negative 2 times positive 4, we'd get negative 8. So we need something that multiplies to be negative 8, but adds to be negative 4. 8 and 1, 4 and 2. That's 6, 8 and 1. No. All right. We'll do the quadratic formula. I was trying to factor. It's possible there's a way to factor that, and I'm just not seeing it. But what we're going to do now is, I spent too much time looking for factors. I don't want to waste any more time on it. So A equals negative 2, B equals negative 4, and C equals 4. Remember, our quadratic equation is negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, so let's plug these in. We've got, let's start with negative B. So the opposite of B is negative 4. Opposite of that is positive 4, plus or minus square root 4 squared. So we need to put that in parentheses, negative 4 squared minus 4 times A, negative 2, times C, which is 4. All right, put our radical, and then we're putting all that over 2 times A, which is negative 2. All right, I'm going to plug in what's in my radical. Just do what's in the radical without the radical. So I'm putting in parentheses, negative 4, close parentheses, squared, minus 4 times parentheses, negative 2, close parentheses, times 4. And I'm going to hit enter, and I get 48. So 4 plus or minus square root of 48 over 2 times negative 2 is negative 4. So 48, let's think of some factors of 48. Let's see if we can simplify this. We've got 2 times what, 24? And 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So I've got 2 pairs of 2. So 48 is going to be 4 square root 3, or 2 times 2 square root of 3. Because of my unions, my pairs of 2's, they got married. 2 became 1, and they moved out of the house. They got out of that radical. So those became 1, 2, and these 2 2's together joined together and became 1 outside there. And I multiplied them together, those 2 right here, multiplied these together to make 4. So radical 48 simplifies down to 4 radical 3. That will not help us with our graph. Oops. That's a horrible parabola. There you go. That's our parabola with the graph, but we are supposed to find the x-intercepts to the exact degree. So 4 radical 3, which will help us to simplify, because if we have 4 over negative 4 plus or minus 4 radical 3 over negative 4. What can we do here? Well, 4 over negative 4 can reduce down, right? We can be left with what? A negative 1 there. Negative 1 plus or minus, these 4's can go away, and our plus will change to a negative, and our negative will change to a plus, so we can really just drop that negative. So we're going to have negative 1 plus or minus square root of 3. And you could put that, that's the x value. The y value is 0. So really how you should answer it is, that's one answer. And then the second answer is negative 1 minus square root of 3, comma 0. Because they're asking for the intercept and not the solution. So we should put it in an ordered pair. But you can see our 3 graphs here and how the base graph of x squared, it started, but then when we started adjusting the formula, the equation a little bit by adding stuff, and it's not just x squared anymore, but now we have 4x and we added 3, how it moved it. It shifted it what? To the left, and it shifted it down. So we have that blue one, and you can see with the green one, it shifted it to the left, it shifted it up, and it flipped it over the x-axis. It had that reflection right there. That negative told us to reflect it or turn it upside down. So in your assignment, you'll be asked to do some graphs, to verify some graphs, but also to fill out these charts. So make sure that you can complete all of this work on your own and get that assignment done, and I'll see you on the next lesson.